So this talk is called Confused Deputy Problem for Database, a case study for my team.
Would you speak just a bit louder?
Okay, thank you. All right. So my name is Alex, and I actually worked with many of you all before. So for those who don't know me, I been working with MySQL. Actually, this is not true. Almost 20 years right now. And I started at MySQL in 2006. Worked at Sun Microsystems, Oracle, Percona, and I joined Amazon Web Services 4 years ago. I started as database engineer, working on RDS MySQL, and then I switched to security. I created a new team at AWS, which we call Red Team. So, what this is about? So, according to Wikipedia, a confused deputy is a computer program. And this is the computer program that is tricked by another program to do something which it is not supposed to. So we have one program that, let's say, runs from root. And we have another program that somehow tells that root program do things. And those things are usually includes assigning a privilege escalation. So let's see how it works for Linux. Let's imagine that we have this common problem in Linux, or maybe not that common problem, where a root creates a files in a user home directory. And this is not good because that user, in this case EC2 user, a normal Linux user, will not be able to do anything with it. So someone created this control, a one-liner, to fix that problem. And what it's doing is it will find all files, which is, well, it actually finds all files and change the owner to EC2 instance to fix that. So the question is, what can go wrong? So I recorded this quick demo on what I call confused deputy problem for Linux. So we have this control, and if I, as a root user here, create a file, then the cron job will run in a minute and fix that. What it will be doing is it will find that file called AAA and change the owner for that file to EC2 user, which is probably the right thing to do. Right? In a second, it will do that. One more second. You're good. But now, our bad actor, our bad user, bad EC2 user, wants to trick it to do something else. What will they do? They will create a symlink. And they will create a symlink to etc password. So they create a file called password, which is actually a symlink. And then what will happen is that the find command will actually follow the symlink. So instead of doing shown on the actual file, it will follow the symlink and change the ownership of etc password to this EC2 user. This is unprivileged user. So if I, as an unprivileged user, can change EC2 password, what can I do? Everything. I can, and we'll see that in a second, right? So now it's changed. We control the EC2 password. Now I can change, I can create a new root user. I can also change my user ID to 0, making it root. So in this case, I have successfully achieved privilege aspiration. Now I'm root. So this is the example of confused deputy column for Linux. Now let's see how it works for the database. So on the database wall, we have a database, and then we have a super user access, and super user controls this whole database. Then we have a single DB, and this is less privileged user, unprivileged user, has an access to that database. So our goal is to get the privilege estimate inside the database. So this is the case study, a confused deputy example for MySQL. This is our assignment for today. And here's the architecture, the example of the architecture, completely fictional architecture, right? So we have a database which is shared internally between a WordPress database and a health records database. Imagine a company which decided to reuse their main production database to host a WordPress website. Don't do this. But technically, this is configured correctly. We have a dedicated user for the WordPress. We have a dedicated healthcare MySQL user. So now WordPress is notorious for its SQL injections. And then our bad actor has managed to do an SQL injection and have a control of the WordPress database. But they don't control the health records. They cannot retrieve the data from health records database. Right? So there's nothing interesting in here, and the real goal of this bad actor is to get to another database. Essentially, breaking the isolation, user isolation between the two databases inside of MySQL instance. Right? So let's examine how it's set up. Again, this is set up correctly, sort of. Right? So basically, we have a dedicated users. One user for the health records databases, only have an access to that database. One user for the WordPress. But we also have this monitoring. So what is this? That's probably some user that is used by the monitoring system. So let's examine more closely. Again, we have all privileges to WordPress database. We have all privilege to health data service database. And then we have a monitoring. A monitoring user is our read-only user, which have a global select, but they also have an execute. So, can we actually confuse that monitoring user to give us a global select privilege? And this is what we will try to do. Right? So if we got a control over the WordPress database, and we will try to retrieve hash of the password, we'll not be able to do that. Select command deny, because this WordPress user doesn't have an access to MySQL system database. But our monitoring user does have an access to that database and can retrieve the hashes of the password because we have a global select. Right? And actually, this is expected from the monitoring user to have a global select to be able to retrieve metrics or metadata from other databases. Right? Those 3 slides is not for you all. And this is basically explain what the database performance monitoring do. This is obvious, right? So it can collect database metrics, log queries, generate, explain queries. And the database administrator will do pretty much the same thing and will use the explain queries to optimize the queries. So now let's take a look at this simple explain. My question to you is, if we run this explain, will it execute the select query? Who thinks that it will not execute select? Right. Who thinks that it will actually execute this select query if you run explain? No. All right. So actually, in some cases, it will. So this has been found by and actually published in Percona blog 2020. Uncommon sense MySQL when explain can trash your database. It is right. So yeah, that's okay. So basically, what we see here is you run the explain on the select, and it will hang because it is actually executing the query. Why is that? The reason for that is explain should show you how many records it will scan. Now, this is a subquery. It has no idea how many records are there in a table which is actually a subquery, a result set of the subquery. So it will go ahead and execute that, materialize that, get a number of records, and output, right? Uncommon sense, it is how it is. And then, again, 2020, I commented on this bug that was open, that this is dangerous, right? What if it will have a cleanup script, right? The cleanup script will delete all the records, and then you do explain on the select query, and then actually executes this thing. But in 2020, I was not thinking about the security. And now the security implications is actually big. So let's verify that in 2025. Let's verify that this is still the case, and it is. Right? You run select, explain select, and it gives you 10 seconds. So it's still there. Right? So how we can leverage that? Let's say that we are pen testers. How can we try to use that to actually get an access to something that we are not supposed to get an access? Right? So remember, at this point, if you control the WordPress database, you have all privileges on that particular database. You can create tables, functions, etc. This is how it's set up, and usually that's a very typical setup. So now, what we can start doing is, we can create that function, exploit function, in that database that we control. And what we're trying to do is, we're trying to retrieve the hash of the password. And we want to retrieve the hash of the password of the monitoring user, right? We cannot do that with the current setup, but we are trying to do that with this confused deputy code. So we check if the user is monitored, and if the user is monitored, we are retrieving the password. Otherwise, we will make this query slow. We'll make it slow so it will appear in different query logs, and someone will try to execute explain. Now, monitoring user have a global select, that's why it works. But how do we get the password back? Also, what we're trying to do is we're trying to run it with a specific SQL security, right? SQL security invoker means that it will run in the context of the user that executes it. That's exactly what we want. Now, the challenge here is how do we get that authentication stream? We put it in a variable. But the thing is that we can create another function, which we call save, which will use a different definer, security definer model, right? This function, as opposed to the previous one, will run in the context of that core WordPress user. And then the monitoring user will run it, and then it will be able to actually write to the database. Remember, monitoring user has a global flag, it cannot write. But because we created this definement thing, it can now run in the context of our user, which have a write endpoint. Putting it all together, actually deterministic, it's not deterministic, right? Just trying to trick my thing. So putting it all together, here's two things that we are doing. If the user is monitored, a user who will be triggering that code, we will retrieve the hash of the password, put it in a variable, and then pass it to the save function, and then we will materialize it, write it into our table that we control. Otherwise, we'll just make this query slow. So how does it work? I recorded this demo, and on the hacker side, I have prepared everything. I have my tables, my functions, and all that proof of concept. So let's verify the current user is core WordPress user. And now there is nothing in this table. And now I execute my poisoned query. I do select, subselect, and then I do the WordPress.exploit function. Okay, so this query is slow, 3 seconds, super slow. So someone else, like database administrator, will go on and try to determine why this query is so slow and run the explain on that. Right, this is monitoring user, run that, and then it will be confused because this query is not slow. But on the other side, we actually get the hash of the password. Right? So what's next? The next thing, we need to actually reverse it. We need to get the actual password. So what I did is I spinned up my GPU EC2 instance. Right? This is the attacker got the hash of the password, right? And then I spin up my GPU instance that may cost me $100 per hour. And then I use this program called hashcat. What I'm trying to do is I'm trying to use the password file, a common password file called ROQ, to find the match for this hash. And I put all this hashcat options to tell it that this is the MySQL native password hash. And let's see how long it will be. We don't know. So let's see. It's running. Starting. Here we go. Less than a second. It get a match. Why is that? Because the password is actually passed. So why do you put that simple password in mind? Well, because it's monitoring. And no one cares about monitoring. People think that monitoring user is nothing, right? It's just a monitoring system. It doesn't have privileges under that. That's not the case. So now, because it has a global flag, we can actually retrieve the healthcare data. Right? So, a quick recap. We confused the monitoring system or database administrator to run explain for the statement that we control. MySQL explain can actually execute the statement, and it should not. Right? And then the third thing is the monitoring user has global select and execute privilege. Right? So, how do we fix that? Server side, this is the bug. It's still not fixed. I think it will make sense to fix that, or at least do something about this problem. Uncommon sense, MySQL explain. A client side, really you need to revoke execute. There are a couple things that you can do to fix that. If you revoke execute from the monitoring user, and if you revoke execute, then this whole thing will not work. But also, if you're using MySQL 8 or later, I would also use I may want to use a way to restrict the MySQL system database, so you can revoke the privileges from the MySQL system database. And then if you think, just one second. If you think that I really made it up, here's the documentation from Percona PMM, where it gives you this create command. This is path, right? So the good thing is that it's not exploitable with this documentation, right? It doesn't give you the example. The example doesn't have execute. This is good. If you follow it, if you start checking your PMM installation right now, you should be fine. But having this is bad. All right. So another recap of the results. We got a monitoring. What happened is we got a monitoring user password hash. It was super simple password. It was easy to crack. And then in this particular case, an attacker can connect this monitoring user and get the healthcare data.
So Alex, one question about this, like a password in documentation, right? Because my worry is if you put a complicated password in documentation, it will be even worse.
Yeah, there's no...
Because it will be kind of look like, oh my gosh, it passed all the security checks. It's, like 20 characters, right? But then because public...
I would just do the not a real password, something like a password example or something. $3 or something.
Or in the documentation, you generate a random key that you put in the file and then you create. You do everything from this.
So, just 2 minutes, it's almost done. Again, this is what we did today. So if we were pen testers, it was a success. We can now file a report and get our bounty. So that's it. That's it. Some conclusions here. Databases are complex. Actually, lots of people think that the database is just data. It's not true. It has code, actual code, functions, procedure, triggers, events, it's all code. Right? A select can be disguised to run code. Also, many people don't quite get that. Right? A select. Inside of the select, there's a function. Inside of the function, that code. Inside of that code is an insert. So select being an insert is really bad. Right? And beware of confused deputy calling for the database. Right? And finally, don't do this. Right? Don't rely on the database having the boundary. Right? We just demonstrated that the boundary between users and databases can be broken. So don't do it. All right, that's it. Thank you very much. All right, question.